Hello YouTubers. Today we are gonna try and transform all this pile here into a Pa0rdt miniwhip antenna. I have tried for so long to get an antenna that is good for AM, but didn't had any success with, and I failed to install an antenna outside of my house due to space constraints. We need a long wire antenna, so I decided to do this miniwhip. It's an active antenna. All the info and schematics are available online, very easy. The owner and designer of this little antenna has done a beautiful job on describing how it works and everything you need to have to build it. There are also some videos out there on other people that have built it. I could have gone with a breadboard, prototyping board type PCB and do some hooking up some components, but I went through the effort and designed my PCB based on the owner schematics we have here. I ordered them on JLC PCB. I went with the matte black finish. Let's open it. See how it is. And these are the PCBs. As you can see, they are beautiful. It's a matte black finish. I have done the antenna on this side and the power supply on that side. It's a linear power supply with a transformer and a voltage regulator. Let's check it out. This is on the back side. There is nothing on the back side. Of course, I made some mistakes. After I ordered the PCBs, I noticed, at least up until now, two things. For the first one is that I forgot this is the input for the 220 volts AC right here, and I forgot to connect them to the transformer pins. They should go here, and there should be a link here. So we're on 220 volts AC here in Europe. This is one mistake I will make with some wires, some jumpers. And also I forgot to connect this positive terminal of the tantalum capacitor here. That's the bulk capacitance for the input of the voltage regulator, and I will make a jumper here, very, very simple, or I don't know, I will figure something out. As for the antenna, the antenna is very simple. We have an exposed piece of PCB here, and on the back side as well, nothing. It's bare PCB here. The copper ends here. This is the ground plane that's covering for the antenna active circuit. We have no copper here. It's a dead zone here. We have the inductor that connects the antenna to the active circuit. And on the back side, as I mentioned, we have no copper here on the back of the antenna, and only some copper on the back side of the active circuit to keep it as quiet as possible, as you can see here. And for the power supply, here is where the transformer is mounted. This is the 220 area. Actually, these are mounting screws, mounting holes for the screws. So all the 220 volts AC is right here. Here we have the secondary of the transformer with low voltage. As you can see, maybe in the light, if I shine the light on it, from here we go to the to a bridge rectifier into the voltage regulator that has some copper exposed here, with a lot of vias from top side and back side, so it had some heat dissipation, which it shouldn't have been needed, but I put it here anyway. And also ground filling here. We have a copper area. Okay, on the top side, everything is nice. Everything looks great. I hope I didn't make any more mistakes. We should try and assemble it. All right, let's start trying to solder some surface mount components here. I will start with the bridge rectifier. I always clean the board up first. I'm using some IPA, isopropanol alcohol. It makes life just a little bit easier if the board is clean. Okay, now let's apply some flux. We have some R8 type flux here. Always a very good idea to have some flux on the board, as much as you can, as much as you like. It's not a rule. We clean the tip of our iron, take some solder. Take some solder here. We tin the tip of the soldering iron. We are cleaning it. I have a relatively big soldering iron. What I like to do is tin one of the pads here. I'm tinning this one just because. We have the bridge rectifier here. Let's see if we can see the polarity. Yes. As you can see on the board, here is the plus sign, and I also have a dot for the pin number 1. Trying to align it as best as I can. Let's see if we can make this work. Try this again. Give it just a little bit. Let's see how this turned out. Decent. Let's do it one more time, pressing on the top of the bridge just to make sure it's pressed down. Now let's solder the other parts. I'm using 0.8 millimeter soldering wire and a relatively big chisel tip here. Let's continue doing. Just apply a little bit of solder. There are very big copper grounds here. It's making soldering a little bit difficult. All right, we will see. We need just a little bit more heat for this pad right here. This is the ground plane, so we just need to add just a little bit more heat. We clean the iron tip, we tin it before we put it back, and let's see what we got, shall we? I'm cleaning again with isopropanol alcohol just to see what we get. If we made nice joints or bad joints. I will clean the board later much thoroughly and much better to have this gorgeous finish intact, so we don't have any problems. Let's take this apart and this apart, and let's try to see what we got here. Bring you in. So too much solder on all of the pads, of course, And on this ground, where is my little pointer? Where is my little pointer? Let me point with the soldering iron, the soldering wire. So I just connected the ground plane on top with the ground plane on the bottom of the PCB here with some vias. Of course, my soldering iron tip being too big for this type of job. Not too big, but big enough. Adding too much solder and being far away with the camera in my front, it was difficult to solder this, and I ended up putting too much solder here. I will correct this later. And also I filled some vias with some solder here. Otherwise, I think the connections are good. The orientation is good. You can see here I have the plus symbol here and the plus symbol here. I also have AC, also have AC here. It's always a pretty good idea to check your orientation. Very good. Okay, let's go forward. Let's try adding this tantalum cap here, and let's go further. Let's see what we can do. Let's bring this into center here as much as possible. I didn't use any thermal reliefs for the pods in the copper ground. Just try to see, it's the first time I do this. I wanted to see how it feels, how good the soldering iron will perform, how hard it will be to solder the things. Okay, a little bit of cleaning, a little bit. Let's add some. Let's tin the pad first, shall we? Okay. Oh, that's the negative terminal, and it's connected straight into the ground plane. It's not liking my 290 degrees temperature. It's I think it wants more. Let's find tantalum cap here. I have a 47 microfarad tantalum cap. It shows some pretty good low ESR tantalum capacitors here. Why was it needed? Indeed. Yes, no, but I like to order my components from a reputable source. Let's add a little bit of flux here. It's always nice to have flux. This is the first time I use this flux. It's an RA type flux. It's a Rosen activated flux. Okay, so maybe you can see, but there is a little plus symbol here. That's the positive side of the cap. And on the tantalum caps, the line marks the positive side of the capacitor. Let me try and work this around so that I can solder this a little bit better. Let's try and put this and align it the best we can. I left the solder pads big enough so that we can introduce the soldering eye here, make our lives a little bit easier. Come on, come on. Is it straight? Let me see. Wow, that was horrible. Ground planes. See now why people like thermal reliefs on their ground planes. Let's add a little bit more flux here, and here as well. We will reflow that joint. Let's take some solder. Still in focus, yes. Place my soldering iron chisel tip flat on the surface and just feed solder in. Not too much, not too little. Of course, we want to press a little bit on the case to make sure it's flat. That looks nice. Let's go on the other side now. Do the same thing. We have already some flux in place. Let's see how it looks. Flickering LEDs. Yep. Hard to solder on a very big ground plane. And on the positive side, we have good wetting action. Just a tad too much solder. I will correct this if needed afterwards. Now, let's try one more thing. Let's try to solder big voltage regulator here. Now let's see how this works out. This should be interesting. That ground plane there with all the vias and the ground plane on the other side as well should be interesting. All right, here we have the LDO. It's a voltage regulator. It's a 12-volt voltage regulator. Let me try to show it to you. It's an LM2937. It's I've had good experience with it. So it will go on right here. It's a fairly beefy voltage regulator. Let's see. Are you okay? Oh, I'm afraid of that big ground plane here. I really am afraid. I'm petrified. And I guess I got it a little bit wrong. See the footprint? I have vias here. I shouldn't have had vias there. Vias were for outside. I guess wrong package size. We will see. Alright, let's add some flux. Flux is always a good thing. Good amount of flux. In there we have the voltage regulator. Let's try to align it a little bit. Let me see. Good thing is this flux is very tacky, so it will stay on the board, will not move, so that's good. Let's see the orientation, not the orientation, the positioning. A little bit to the right there, and I think this looks quite good. Let's try to dab a little bit of solder here. Okay, so we did one pin. Now let's do the others. I will try with this one. Let's try it, but a little bit less solder this time. Okay, now this middle pin is the ground pin. So this will be tricky. Okay. Wow, that is tricky. Good. Let's see how this ended up. Meh. Goodish. It's okay. For the big tab, let's try it this way. And for the big tab, I will try to change the iron because I don't think we will succeed in doing anything. I will bring get the big guns out. This is bigger and a little bit more beefy soldering iron. It also takes a little bit more time to heat it up, but once it's heated up, we will have no problem whatsoever. We have it on 290 degrees C. Let's see how this big bad boy does with all this. Oh, this is beautiful. It's like butter. It's working, it's working, it's working, it's taking its time, it's working. Okay. A little bit more solder. And probably it's ready right now, but just a little bit more solder will not harm anybody anytime soon. This wouldn't have been possible with the regular soldering iron. Okay, so we need thermal reliefs for next projects. Let's try and keep that in mind. Let's see what we got. Okay, I think it's a good solid, as solid as it can be. Connection there. Is it standing a little bit up? Wow, everything is hot on the backside, and we have solder coming out through the vias. How good you can see this. Lose focus, but everything is hot around here. Warm. I can keep my finger on it, but oh, here no. Let's see the part. It's okay, mildly warm. So that's it. Let me finish the board and I will come back with the finished product soon. Yes, thank you. Okay, so here we have the power supply soldered. I will do a final cleaning afterwards. So what do we have here? This will be where the transformer will be mounted. Here we have the bridge rectifier with a bulk capacitance of 45 microfarads. A reservoir. We have a 100 nanofarad, a 0.1 microfarad ceramic cap here, 50 volt jobby. We have the voltage regulator which is gonna regulate everything, and we will be outputting around 12 volts DC. We have another filter cap here on the outside of the output of the regulator. Also, we have another 100 nanofarad cap. There is no bin counter here, so we can do. Okay, so my power supply, it's completed. I will test it in just a second. You see, I've made a little put a little bodge wire here from the positive side of my capacitor here to the positive side of my diode bridge rectifier. Everything is solder. I mounted the small transformer here. It's a signal transformer. I don't know what it is, but works very, very nice. It has two primaries. You can set them in parallel for 115 volts operation, or in series for 230 volts mains. We have a 12 volt AC output, 50-60 hertz. Everything is perfect. Now all I have to do is make a connection from here to here, the intermediate pins, and from the outside to these pads here where the mains will be connected. So let's do that and I'll be right back. Alright, what we have here set up is I have connected the power supply, the AC supply. This comes from an isolation transformer and the variac. I will slowly increase the AC voltage. You can see it here. Now it's 1.6 volts, and here we are monitoring the output of the power supply. We should get roughly around 12 volts DC. So here we go. We are also current limited on the power supply. We can see some action here. We are at 100 volts AC. Let's go higher, 150, and we have reached stabilization. Let's go. This is around 220 volts. Let's hit around 230. This is what the outlets in the wall in Romania are around. 235, 230, somewhere around here. We can see we have 11.88 volts unloaded supply output, which is correct, which is okay, no problem whatsoever. So we have a success. I will test some more voltages and we can call it a good power supply. Okay, I've turned around the power supply. Now we can take a look at some voltages here. If we look at the output of the power supply, we can see we have almost 12 volts. The drop, or the difference between the 12 volts and 11.88 is this Schottky diode, because on the input of the Schottky diode we should have 12 volts, and indeed we have. Let's see, on the output of the regulator we have 12.1 volts, rock solid. Let's go on AC volts and let's see what ripple we have on the output of the bridge rectifier. We have about 182 millivolts, which is decent. On the output, on the input of the regulator, it should be the same, 182, 83. It's good. Let's try and take a look at the input of the bridge rectifier. The output of the transformer is about 15.4 volts AC, which is good. So we have a DC output from the bridge of about 20 volts. So on the input of the voltage regulator we have 20 volts, and on the output of the voltage regulator we have 12 volts DC. So we are dropping about 8 volts on the voltage regulator. If I may find the calculator here. Eight volts drop multiplied by 0.05, a 50 milliamp load. I am expecting that would be 0.4 of a watt. 0.4 of a watt will be absolutely no problem. I don't think it will get even warm in the voltage regulator. Okay, now here we have the antenna board. You can see the antenna. We have a coil that couples the antenna to the input of this JFET. This is a little JFET. It's a J310, which goes further through a capacitor, a blocking capacitor, and a resistor into this NPN broadband amp. It's a 2N5109. Let me turn the board upside down so maybe we can get a better look at it. Okay, let me take something to point with. So we have the little amplifier here, a blocking capacitor, a small resistor. We have some bias resistors, some bypass caps here, a coil to filter out the power supply. I am yet to install the 2N5109 here, and here will go the connector. We will have the connector, and I finished soldering it. This was quite difficult to solder under that magnetic shield, the big inductor, as you can see. Maybe if we can get it to focus a little bit. Yep, okay. So this is what we have. That was tricky to solder. I soldered it with hot air first, and then I used a very fine, pointy, conical tip. And this light is buggering me. Okay, let's see now. Okay, you can see how the JFET is soldered. Everything is soldered properly. We have everything connected, even our little coil there. Everything is fine. All the joints are good. What is remaining is the amplifier NPN transistor, which has some pads on the other side. I will solder it from the other side, leaving just a little bit of space there. So I'll do that and I'll be right back. Okay, so we now have our transistor installed. As you can see, everything is good. Okay, so here we have the antenna finished. I have connected it to the power supply. We are currently drawing around 10 volts. As you can see, surrounding objects influences the voltage drop and the current consumed. But we are actually measuring 10 volts and we have a current draw of 42 milliamps for the antenna, so everything looks quite okay. I think we are ready for a test with a little radio. Don't you agree? Here we have a little radio. I have hooked up the antenna. This is now with the antenna hooked up, but the power supply is off.